Assalamualaikum and hi, I'm Shikina Aziz. Soil in food processing are unwanted matter on the surface and need to be cleaned. There are many types of soils that may form or left in food manufacturing area. You may refer video entitled "What's Soils in Food Factory?" Okay, that is my previous video. For if you want to if you want to get a general description on salt, you need to refer that video. Okay, that video exactly provide a brief description on salts that may present in food factory. It is important to identify the characteristics of the soils because the characteristics provide information on how they may be solubilized so that we can speed up the cleaning or the removal rate. Now I'm going to describe inorganic soil, or also known as mineral deposit in food factory. Inorganic salts that may present in food processing area are limescale, calcium soaps, silica, iron oxide, oxalate crystals, and miltstone. Water is considered hard if it has a high concentration of dissolved minerals like calcium, magnesium, uh, and these are main minerals that often found in water supply. Besides that, dissolved fluoride, sulfate minerals may also contribute to hard water characteristics. The presence of these minerals can make significant problem because it can form limescale. Limescale consists mainly calcium carbonate, but it can also contain small amount of magnesium hydroxide, calcium sulfate, and other compounds depending on water composition. Limescale, okay? The formation of limescale is influenced by many factors such as the water hardness, concentration of solution, pH, and ionic strength. And limescale may cause significant problem as it can precipitate and clog the pipe. Furthermore, limescale can reduce the lifetime of equipment, raise the cost of heating and the water for cleaning, and lower the efficiency of heat transfer if proper control is not done. And limescale is generally found in evaporator, boiler, and cooling tower or cooling power plant. In order to control the formation of limescale, we should check the deposit, verify the water hardness, the regeneration cycle of the water softener, and the result of the softener over cycle. And for cleaning, you need to use acid detergent or detergent containing a strong chelate. Hard water may generally contain calcium ions and magnesium ions. These calcium and magnesium ions will also react with soap. For example, sodium soap to form calcium and magnesium soaps, which are not soluble in water and also known as soap scum. Soap scum, or other name for it, is lime soap, is also classified under mineral deposit. Common factors that influence the formation of soap scum are the water hardness, fatty acid, and concentration of the solution. The formation of soap scum, and limescale contribute to the same problem where it precipitate, clog the pipe and may reduce the efficiency of equipment. You may notice soap scums, stains, or white deposit or film on piping, tank, and equipment surfaces. The same control for lime scale is also applied in controlling the soap scum. Then let's look on silica scaling. Silica scaling may also form on pipe or equipment surfaces. Silica can be found in all natural water supplies. Generally, the formation of silica scaling is influenced by the water quality and the concentration of silica. Problems that might be raised from silica scaling is the same as the lime scale problem. Silica scaling may be found at any surface that contact with water, especially water that has high silica content. In order to control silica scaling formation, it is important to check the silica content in the water and then maintain low silica concentration, which is normally below 0.02 ppm by using external treatment equipment. And cleaning for silica normally be done with special acid, and this is I recommend you to consult chemical supplier because the acid that will be applied to clean the silica normally is very hazardous and very strong and dangerous. You need to wear a special PPE and complete PPE basically. Then if there is a red, brown or black flaky deposit or film on the deposit equipment surfaces, this indicate the iron deposit formation or mainly iron oxide. The formation of iron deposit may due to high iron in water supply, low pH of incoming water, and iron corrosion. Iron oxide scaling may happen at any metal piping and equipment after exposure to air or to moisture. And there are ways to control iron oxide scaling by checking the iron content in water supply. Use equipment that is fabricated from anti-corrosion metal. Anti-corrosion metal is a metal which has been treated, for example, galvanization and surface plating. Beside hot water factor, mineral scale. Okay, beside hot water factor, mineral scale can also caused by the raw material of the food processing. For example, oxalate crystals, which normally found in calcium oxalate form. Oxalate crystal looks beautiful under microscopy, but they are hard and very difficult to remove. Oxalate crystal can be found in breweries industry. The formation of oxalate crystal in breweries industry is also known as beer stone, and its formation is due to the chemical reaction between the alkaline cleaners, water hardness, and protein. When the buildup of oxalate crystal become larger, it may flake off and can be seen in draft beer as white or black specks, which will cause the beer to have an off taste. While in spinach packing factory, spinach is high in calcium and oxalate. Generally, for every 100 grams of spinach, it may contain 750 milligrams of calcium oxalate. Usually, it will deposit during transport and washing process. The removal of oxalate crystals can be done by phosphoric or nitric acid mixture at 60 degrees Celsius, and oxalate crystal dissolve with these acids. And it is also important to note that Inorganic soil is usually combined with organic soils to form fouling deposit in food processing equipment. Millstone is one of the examples that commonly form in dairy industry processing lines and equipment. Millstone is a mixture of calcium phosphate, magnesium phosphate, fat, and condensed proteins. When milk is heated over 60 degrees Celsius, phosphate or mineral starts to precipitate on the heated surface, then followed by protein deposition and fat. The deposit sticks firmly to the surfaces, and if the heating process prolonged, the color of the deposit will change from whitish to brownish. The main factor for millstones formation are due to heating the milk at over 60 degrees Celsius and the composition of the milk that has calcium phosphate and magnesium phosphate, fat, condensed proteins. The millstone will remain in the processing line if the washing process is incomplete. Millstone can cause same problem as other inorganic scale, and millstone can form at any surface that contacts with milk. Thus, it is important to weekly check on the equipment to ensure the cleaning, chemicals, and procedures are sufficient. Common practice in dairy industry, ultraviolet light is used to detect the presence of the millstone. For cleaning, acid detergent is used to remove the millstone. Now, let's conclude the contents of this video. All the organic salts, which also known as mineral salts or mineral deposit or mineral scale, as shown here. Okay, we have 6 types. Okay, 6 main types that commonly be found in food industry. Okay, they are actually water insoluble salts. Okay, these salts are difficult to remove and will need acid detergent to dissolve. In some applications, the formation of inorganic scale can be controlled by controlling the water hardness and the operating parameters. Okay, I think that's it for now. Thank you for watching. Bye.